Today we are going to be learning about AWS Cloud Computing. So let's begin. First, let's start off with what cloud computing is. So the definition of cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. So AWS started its cloud computing back in 2006, and this is when they sold their IT infrastructure services to businesses as web services. By doing so, it provided a simple way to access servers, storage, databases, and a broad set of application services all over the internet. A cloud services platform, such as AWS, owns and maintains the network-connected hardware required for these services, while you, the user, provision and use whatever you need. This helps build and run applications. The cloud can also be used for the deployment and management of applications. It is available to hundreds of thousands of customers across 190 different countries. And all of this is available with powerful resources at low operational cost. Usually, provisioning your services is like a Goldilocks problem, where it's hard to get just right. However, with AWS, you can elastically scale up or down your usage so that you can get the exact amount that you need. So what are some benefits of the cloud? So the cloud will give you the ability to deliver innovative new features to the market much quicker. And by doing so, you can focus on adding differentiated value. It also makes new ideas feasible that were once out of reach. Experimentation will become fast and low risk, and you can adjust the cloud usage to fit any workload. This helps businesses serve their customers globally without the need for expensive, time-consuming expansion. You can deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, and more. And the cloud can connect to personal infrastructure by a private dedicated connectivity. So what are some additional cloud benefits? You can trade capital expense for variable expense so that you pay only for what you consume and only when you are consuming. You can benefit from massive economies of scale where you get lower variable costs and achieve higher economies of scale, all leading towards lower prices. You can stop guessing about capacity and you can access as much or as little of the cloud as you need. And you can scale up or down when necessary with only a few minutes' notice. Next, you can increase speed and agility and reduce the time it takes to make resources available, causing a large increase in agility due to cost and time to experiment becoming extraordinarily lower. And you can stop spending money running and maintaining data centers, as the cloud will take care of that for you. And instead, you can focus on your own customers. Lastly, you can go global in minutes. You can deploy your application in multiple regions around the world extremely quickly in just a few simple steps. And this means you can provide lower latency or the delay before transfer of data and a better experience overall for your customers at a smaller cost. So what is total cost of ownership? Total cost of ownership, or TCO, reduces the need to invest in large capital decisions. And instead, it provides a pay-as-you-go model that allows you to invest in the capacity that you both need and use. And TCO calculators allow you to estimate the cost and savings. Calculators also modify assumptions that best meet your business needs, and calculators provide directional guidance on possible savings. The tool is built on an underlying calculation model, and it generates a fair assessment of value that a customer may achieve by switching to the cloud. However, TCO calculators results should only be used as an approximation, not an exact measurement. So this is a video that you can watch for additional information on cloud computing, and as always, it will be linked below. Next, what are the types of cloud computing? So there are several different models of cloud computing, and they all allow for different amounts of controls of web services. The three main types are infrastructure as a service, platform as a service, and software as a service. So what is infrastructure as a service? This contains the basic building blocks for cloud IT, and it typically provides access to networking features, computers, virtual or dedicated hardware, and data storage space. It provides the highest level of flexibility and management, and it is the most similar to existing IT resources. Furthermore, it allows for instant computing infrastructure. Next, platform as a service removes the need for organizations to manage the underlying infrastructure, which is usually the hardware and operating systems, and it allows focus on the deployment and management of applications. This helps business owners to be more efficient, and you can disregard human concern over resource procurement, capacity planning, software maintenance, patching, and more. The combination of hardware and software components are all provided. Next, software as a service. So this provides customers with a completed product that is run and managed by the service provider. Software as a service is usually referred to as end user applications, and because there is no user concern about service management or how the infrastructure is managed. You only need to know how you will use the software. For example, web-based email is an example of software as a service. Here's a video about the three types. Next, how to deploy the cloud infrastructure easily. So there are four key areas that can all help to make deploying cloud infrastructure easy. The four areas are highly trusted global infrastructure. This is designed for high security and availability needs of the large enterprises, and it offers capabilities that restrict unauthorized access or usage without sacrificing any flexibility, as well as providing a backup for all features. Furthermore, it provides broad compatibility with all workloads. And you can spin up virtual servers, hard drives, databases, networks, and more. And it can easily set up virtual servers using Linux or Windows. Next, fast and secure private networking. You can provision a certain section of the AWS cloud that you define and retain control of. And this is done through simple IP networking. And the cloud environment will then become an extension of your on-premises environment. And this uses a standard pipe that encrypts data when it moves from your environment to the cloud. And then more data creates a dedicated network connection from your existing data centers to AWS, which gives you predictable network performance increase by bypassing the public internet. Lastly, the switching to the cloud can give you tools to control access on all cloud resources. You can create and manage users and integrate with your own existing identity systems, and you can give greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of AWS. So, what is the cloud? The cloud-based applications are fully deployed in the cloud. Applications in the cloud are created in the cloud, or they're migrated from an existing infrastructure to take advantage of the cloud infrastructure benefits. Cloud-based applications can be built on low-level infrastructure, and it can also use higher services that provide detachment from management, architecting, and scaling goals. Next, what is hybrid? So, a hybrid approach is a way to connect infrastructure and applications, and it connects cloud-based resources with existing resources. So, a common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting cloud resources to the internal system. And this way, you can run applications in both the cloud and on-premise, as well as accessing AWS wherever it is necessary. Lastly, on-premise deployment. So this is referred to as the private cloud, and it uses virtualization and resource management tools. So, on-premises deployment leads to the inability to receive cloud computing benefits, and it is used to provide dedicated resources. This is typically the same as previous IT infrastructure, and it uses application management and virtualization technologies to attempt to increase resource usage. So, here is a video about the cloud versus hybrid versus on-premise deployment. All right, lastly, we have AWS security. Sorry, not lastly, but this is day 4. So AWS infrastructure installs safeguards to protect privacy, and data is kept in highly secure data centers. This manages dozens of compliance programs. Segments of compliance have already been completed within AWS, providing the highest security without the user having to manage their own facility. This also helps save money at the same time, as you can scale your security with your AWS cloud usage and maintain a level of security that you want regardless of the size of the cloud. Here's a video about AWS security. So now we're going to talk about all the services AWS Cloud Computing can provide. So first we have AWS Analytics Services. These are a set of services that handle every step of the analytics process. Services are powerful, flexible, yet simple to use, and enabling organizations to put their unorganized data to work efficiently. Some example services that fall under this category are Elasticsearch, Kinesis, Redshift, and Athena. So Elasticsearch is an open source search and analytics engine used to log analytics, real-time application monitoring, and user click analytics. Kinesis enables you to absorb, buffer, and process streaming data to find insights promptly. Redshift can ask questions and combine exabytes or a 10 to the 18th byte of organized as well as disorganized data across your data warehouse, operational database, and data lake. For those that don't know, a data lake is a centralized repository that allows you to store all of your structured and unstructured data at any scale. And it does all of this using a language called Standard Query Language. And then lastly, Athena is an interactive question service that makes it simple to analyze data in Amazon Edge 3 using the Standard Query Language. Next, AWS Compute Services. So AWS offers multiple services that can deploy, run, and scale applications as virtual servers, containers, or code. And some examples include Amazon EC2, Amazon Lightsail, and Amazon Elastic Container Service. So Amazon EC2 obtains servers quickly and inexpensively. Amazon Lightsail creates a virtual private server on AWS. And Amazon Elastic Container Service runs in Docker containers. Docker containers contain software that are standardized units, and containers package everything the software needs to run, including libraries, system tools, code, and runtime. Next, AWS Database Services. So these are necessary databases for applications such as managed relational, non-relational data warehouse, in-memory data store, and graph databases. And Amazon DynamoDB is a fast and flexible database service for any workloads where you pay only for what you utilize. Key value databases that delivers nearly instantaneous single-digit performance at any scale. DynamoDB is built to handle internet applications, and it is a fully managed service that handles more than 1 trillion requests per day. Amazon Relational Database Service, or RDS, is a relational database service with 6 well-known database engines and can be set up, operated, and scaled in a few short, simple steps. And here is a video about that. All right, so let's discuss the final few tools that we have. First, AWS Developer Tools. So these contain code and automatically create, evaluate, and deploys applications. And it is a set of services that can quickly and carefully deliver software. These services store and hold control of your application source code, and it is used for constant integration, continuous delivery, infrastructure as code, and monitoring. AWS Code Pipeline AWS Cloud Development Kit, and AWS Code Deploy are all examples. AWS Code Pipeline can create end-to-end software release workflow using services and provide continuous delivery service that automates the release of pipelines in order to have fast and reliable applications as well as infrastructure updates, and it can effectively and efficiently deliver features and updates. AWS CDK is an open software development structure that helps to define your cloud application resources using known programming languages, and it supplies cloud and applications can be supplies cloud applications and can be a challenging process that requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. However, AWS CDK utilizes a familiarity and expressive power of programming languages to model your applications. Code Deploy is a tool that installs applications and updates servers. It lowers the workload on developers and quickens the release of new products and features. Code Deploy makes it simple for you to release new features, help dodge downtime, and deal with the complexity of updating applications. Some positives include automated deployments, minimized downtime, centralized control, as well as the fact that it's quite easy to adopt. Next, AWS Management Tools. These tools allow you to provision, monitor, and set forth your cloud environment. You can maintain stable control without restricting your development speed. AWS Cloud Watch is a service which was built for developers, system operators, site reliability engineers, and IT managers. CloudWatch provides information and insights to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. This gathers monitoring and operational data in the form of logs, metrics, and events, providing you with a linked view of AWS's resources, applications, and services that run on AWS and on-premise servers. AWS CloudFormation provides a common language to supply important assets in the cloud, and provisions can be automated to be sent over and over again. This models infrastructure using the simple text file. AWS Systems Manager allows full control of the structure of AWS. You can automate tasks needed for smooth operations, and this helps guarantee security and compliance as well as detecting problems quickly. AWS Networking and Content Delivery Services allows you to isolate your cloud infrastructure, scale request handling capacity, and connect physical network to private virtual network, and the networking products will work together to meet the requirements. Elastic Load Balancing coordinates with Amazon Virtual Private Cloud to give networking and security features, and this helps distribute application traffic among different services. And it handles traffic in one or multiple availability zones or data centers. And all of this is done to improve scalability or the adjustability of applications. Next, AWS storage services are reliable, secure, and adjustable locations for your data. AWS offers a wide variety of cloud storage services to support both application and archival compliance requirements. Archival requirements are the dates when things can be archived, and one can choose from different options to build the base of your cloud storage management solution. In AWS, the different types of storage services include object storage, file storage, block storage, backup, data transfer, and edge computing. So here's a video about all the different types of web services. That's it for today. As always, all the videos will be linked below. And I hope you learned something and enjoyed the stream.